Day 14. Where are we at? We are at trying to fix this. That's right. Alright, so we've got essentially two sets of rectangles. One of them is in screen coordinates, just pixel coordinates. Another one is in world space. And the ones that are in world space are scaled up, because the source art is low resolution. So we need to generate multiple resolution versions of those somehow. Put them somewhere and then select between them. Okay. So this camera half-span thing. Okay, so this should just be source, I guess Sprite scale multiplier or something like that. And we're just gonna set that to 1. And yeah, so height over width, we do need that. Well, actually, do we? We're passing in window dimensions, so we don't actually need this at all anymore. We do need this sprite scale multiplier thing. We do need the camera position, texture dimension, and window. So text dim is actually atlas dim. Okay, so that is atlas dim. Okay, window dimension, atlas dimension, camera position, sprite scale multiplier. Alright. Yep. Okay, so we're not passing that in anyway. What's the point? If we're passing in window dimension, there's no reason for that. Now let's do the everyone's favorite thing, which is synchronizing data structures. Window dim, atlas dim, camera position, sprite scale multiplier. Okay. Float. Okay, there's sprite scale multiplier. Okay, now in here we go in. So screen coordinates actually don't care about any of that. It's only the sprite shader that cares about it. Okay, so what are we using camera half span for again? To figure out position. Yeah. Okay, so sprite scale multiplier, that's just what you yeah, I think we can figure this out pretty easily if we just go window dim divided by sprite scale multiplier. I mean divided by 2. Yeah, I think that does it. Because if the window, if there are 1,000 pixels and we're multiplying everything by 2, that means we see essentially 500 source pixels. Yeah, so that's it. That's the camera half span. So now, right now, it's 1:1. Does it compile? Yes. Okay, so we're crashing because of reasons. Oh yeah. Of course, it needs to be aligned to 16 bytes. So yeah, let's just do a pad. I think we're missing 4 bytes. Is that it? Yeah. Okay, there it is. So this is 1:1. And it does seem to be drawn in the correct places and everything. Yeah, and yeah, I think I see bilinear. Well, actually, we can see, we can look at bilinear. If we just zoom in. Oh yeah, it's not focused. It's yeah, I mean that is how we want these things to move around. Okay, now let's scale it up. Except that, you know, well, there's two parts to scaling it up. There's setting the scale multiplier. And then there's selecting the appropriate sprite. Yeah. Okay. Yeah, probably 8x is about as large as we need them to go. So 2. Okay, so, well, we can include 1. Why not? Okay, yeah, so I kind of want to be able to switch between these easily. Although right now this is easy enough, I suppose. Yeah, let's just go to 2x. And, alright, so if we zoom into that, I think we see some, yeah, we see issues. Source art is lower resolution than it's supposed to be, so it's blurring it out. And to fix that, I'm going to generate high resolution versions of these things. So let's just do 2x for now and see how that goes. So this is where we're pulling out the textures. So while actually, yeah, so we pull out the textures, right? And so if we go to this Atlas ID thing, yeah, these are the textures that need to be scaled up. And we don't actually have to scale up anything else. And, well, okay, hold on. I need a bit of a toilet break. So let me just set up a timer. Yeah, that'll do. And turn off the microphone. So the mips aren't required for the font, they aren't required for the white pixel, they're only required for the sprites. So I figure we can go in and say that, so this is the sprite input. So we have this position in Atlas, right? Can we just do struct rect here? Float to top left, float to text, dim. Yeah, we can. But then can I do rect text in Atlas? Like, is such power possible? Can I do that? I mean, it would have to have a... Oh. Well, okay, let's see if that works. Okay, so text in Atlas dim is text in Atlas dot dim. Oh, actually, this offset. No, I mean, it's still one-to-one, it's just we're gonna have to select different MIP level. Yeah, but we're essentially assuming that text in Atlas dim is the size. Yeah, well, we'll see how it works out. Text in Atlas dot top left. Okay. Well, okay, so this is not gonna work because our descriptions of the input are not right. Yeah. Oh, we have symbols. Symbol names. Interesting. Yeah, so this is text and Atlas. Okay, well, that's not gonna work, obviously, because like we have to have this format thing, which is like, I mean, unless you yeah, we're not specifying the size here, so yeah, that is not gonna work. So let's just kind of revert these changes real quick. Okay. So let's go through these sprites again. Alright, so we can work out the counterhouse for now. Offset for center. So we are assuming that the texture dimension is the world space dimension. And if the offset is 0, then the center needs to be moved to the right. That's the idea here. Okay, and then there is the offset position. It's input position plus this offset position. Yeah, I think that should still work. That should still work. Okay, so how... So we have these IDs here for which correspond to Sprite files. And most of them, well, except the special one, I suppose, most of them are going to require... I mean, the special one doesn't even really have to be done like that. Well, can we move the white pixel out of... Can we just generate it? Just like we're generating font? Yeah, so we're just generating a texture here. Font.text, there it is, which is just here. So we can just do that instead of having a whole Sprite file of course. Texture, white, fix texture is width is 1, height is 1, and pixel is white, fix text pixels. Data 0x ff like that. Yeah, that's an array. Okay, and then atlas ID white pixel is white pixel texture. Okay, and that's it. So now this this white pixel thing can just go away, and presumably it'll still work. Yeah. So if we look in render doc, yeah. Inputs. Yeah, so we still have that white pixel over there hanging out. Alright. Okay, so now everything that comes from Sprite needs to have... yeah, so we don't have this anymore. Now everything that comes from Sprite needs to have mipmaps created. And right now the texture is created here. So we could just go through that. I mean, we could just create it right here, right? So mips, yeah, that's what I'm doing. So, alright, where are they gonna go though? I mean, I guess atlas ID, like, we could just put them in here like this. 1, 2, 4, 8, you know, something like that. Well, before getting to that. Okay, 1, as in like 1x, 2x. Okay, I mean, this is definitely getting into the I have to auto-gen this territory. Well, let's try it this way anyway. Commando 1, Lemurian 1. Yeah. Okay, so because the scale multiplier is 2, these would have to be 2 as well. Okay, so this is what changes, essentially, and nothing else changes. Yeah, so that determines which one of these you're using. Okay. So then in here, well, everything up to here works just the same. It's just after this, we have to go through and create in mip count. Total mip count right now is 2. So for mip, I guess scale factor is I guess mip index is, well, starting at 1, mip index, because we already have the 0th one, that's just 1 to 1. Mip index is less than mip count, mip index plus plus. My32 scale factor is, well, we're starting at 2, and at the end we're just gonna do scale factor multiplied by 2. Okay, so mip index 1 means scale factor 2. Okay. Okay, now we need to blow up the texture. Okay, texture miptex. Miptex is, okay, so width is texture width times scale factor. Height is texture height times scale factor. Is there an error here or something? No. Okay, so that's the miptex. Now miptex pixels. Like, you gotta love that language support. Miptex pixels is arena. I like array. What arena are we using? Scratch, I assume. Yeah. Type U32 count. Well, it's miptex. Width times miptex height. Pixels is that. Okay, so we've got the pixels allocated. Now just fill them in. For I32 row is 0, row is less than, I mean, I guess this is OG row. Texture height, OG row plus plus. For OG column is 0, OG column is less than texture width. OG column plus plus, okay. So these are the original pixels. So we can just pull it out. I32 OG index is OG row times texture width plus OG column. Okay, U32 OG pixel is texture OG index, and no texture pointer. now that we have the pixel, we just go into like 4 I32 miptex. It's like a scale, like repeat rep index is 0, rep index is less than scale factor rep index plus plus. Okay, so this is the repeat index, and we essentially want miptex pixels pointer miptex index plus rep index equals U32, I mean equals OG pixels. Well, it's with scaling in both directions, so okay, so it's I guess miptex row would be OG row times scale factor. To miptex column is OG column times scale factor. Okay. Okay, so this is the OG index, and with I32 miptex index is miptex row times miptex width plus miptex column. Okay. Yeah, so that's like the top left of what we're filling. And we just need to fill that rectangle. Except that, given that we're filling it, we have a top left, and we kind of want to fill a rectangle, right? So maybe what I should be doing instead is like 4 I32 rep row is what scale factor? Rep row plus plus 4 I32 rep column to rep column scale factor rep column plus plus. There we go. And in here I can work out, so it's OG row plus scale factor plus rep row, and this column is actually column times scalar plus rep column there. And so the index is a row times width plus column, yeah. And now I can fill it like that. So it's something like this. Pixels. Why did I type I32 here? I don't know. Pixels pointer, no. This is not a thing. There we go. Okay, so that's the MIP. Well, of course we have to put that into these textures. So this would be this mip ID. This ID, actually this ID plus mip index. That'll do it. Okay, so I don't really know what's happening exactly. Let's look in render doc. Yeah, we have it. Save, no, save. Did it save the thing? Yeah, now it did. So color passes, draw instanced. Okay, it looks like we do have different versions of these things, except that we want mip text saved here, not the original texture. Okay, let's see. Alright. Launch, save, no. Capture, go on, color passes, draw, like there's the texture. There we go, there's the scaled up versions. Okay, so it looks like we are scaling them up appropriately. Of course it's black background. Yeah. And then there's the originals. Yeah, okay. Well, we have MIPS. Now what's going on in the meshes? Let's see. So we go in, this is via Sprite, we are going, okay, so Sprite scale multiplier is 2.0. Hold on, if we zoom in, they're still kind of blurred out. It's like, are we actually using the correct pixels? Well, I mean, we can see that here probably. So text and atlas top left 0, 0, dim is 2026. Yeah, that does sound correct. Okay, what's camera half span? 640, 360, 640 sounds right actually. Well, I mean, if we're giving it the correct texture, which is that one, and we're drawing, it's like it's being drawn too big or something. I mean, unless it's like not aligned with the pixel grid. Like there's no. Okay, well, it doesn't look like there is an orientation where it is aligned, which is wrong. What do we have here? Well, we have that offset for center, 10 pixels, 13 pixels, camera half span. Offset position, yeah. Position and clip. Well, that's the position and clip. Okay. Vertices. Yeah, I don't really see like the. Okay, well, what's the dimensions again? So the dimensions are meant of the texture at 2026. And if we look at the output, like how big is this thing? I mean, it starts at 12. It's around 1280, and it goes until about 13. Well, actually, it goes twice that. So this is like 40. Is there an, hold on. It's like I'm dividing by 2 where I shouldn't be. half span. Well, window dimensions would be 2560. So 1280 on the X would be the half span with the 1-to-1 scaling. So that would be window dim divided by 2, but since sprite scale multiplier is 2, we divide by 2 and divide by 2 again, so camera half span ends up being 640. As in 640 world units. Can it stop blinking? Can the cursor stop? I can't type here. Why is the cursor blinking? Okay, so that's the position clip, dimensional clip. Position and clip, camera, position and camera space, which is blinking cursors, so annoying. Position and camera, and there it is, 10 minus 13. I mean, sure. Dimensions of the texture divided by camera half span. So 20 divided by 640, that would be the dimension clip, which is 0.03. Yeah, so hold on. So we've got like 20 divided by 640, and then we just multiply that by 1280, right? 40 pixels. I mean, it's supposed to be 20. Okay, what am I? Was this always wrong or something? Like, this seemed... Oh, wait. Okay, so the camera is seeing 640 source pixels to the right. So that's correct, yeah. But the texture should still be drawn 1-to-1. Hold on, first of all, what if I go back to the 1-to-1s? Say this is 1, and all these underscore 2s, let's say they underscore 1s. And we go in. Okay, so this is correct. So this starts at 1280 and it goes until 1290. So it's like 10 pixels approximately. Okay, so let's just think through this again. Camera half span is how many world units the camera is supposed to be seeing. Like up and to the right, from the center. So that's the window dimension divided by 2 for the half span, and then divided by the sprite scale multiplier. So with 1:1 it's seeing 1280 screen pixels and also 1280 world pixels. The dimensions of the object. Oh yeah, so this needs to work differently actually. Yeah, this first part needs to work differently. Specifically because we're not scaling anything up. Okay, let's just remove camera half span so it doesn't get in the way. Text and Atlas dim, it has the correct dimensions, and we're just drawing it 1:1. So position in clip space should be position in camera space divided by the camera half span. Not divided by the camera half span actually. Wait, is it? Wait, no. Oh. It's the dimensions in clip space that are that needs to be divided here. So if the texture is 10 pixels, it's 1:1 with the... Those 10 pixels should correspond to 10 screen pixels. Which means that in clip space, if the window width is 1000 pixels and the texture width is 100 pixels, then that's 0.1. But in clip space that would be 0.2. So times 2, we'll divide by 0.5 times 2. Well, first of all, let's check that 1:1 is working correctly. Yes, zoom in. And let's see, we're starting at 1280 and we're ending at 1290. Yeah, so that seems correct. Now we go in, we change the scale multiplier thing. So we're starting at 1290 and it goes until 310. Okay, so at least in terms of dimensions, this is what it's supposed to be. Okay, so launch, zoom in, and move around. Yeah. Okay, well obviously the offset's wrong, but the movement's correct. So that's something. Yeah, okay. Now let's think about the offset. As the offset is specified in world units. Yeah. Which is not this, right? It's because the texture is referring to the 1:1 texture, scaled up texture. Okay, so the offset is specified in world units, which means the offset of 0, so yeah, this is position. This is position. out to world unit position is, wait, not position, world unit dimension is this dimension divided by sprite scale multiplier. Okay, so this should be world unit dimension. Position is in world units, now offset is in world units. Position in camera is this offset position in world units minus camera, which is also in world units. Then we divide by camera half span, which is in world units. That's what this division will do. And then it's just dimension in clip space, which would be dimension in world units times the sprite scale multiplier, which is just this. And then you scale it essentially appropriately to the window. Okay. Yeah, that seems correct. Let's turn off movement. Well, oh god. So it's the left edge that's, I mean, there's an extra pixel here, right? So like, yeah, so we're rotating exactly around the left edge. Or flipping, I guess. Exactly around the left edge. Which makes us aligned with the slower version of ourselves. Yeah, so that seems correct actually. Okay, well, so presumably the MIPS are working. Now it's to figure out how to actually, because I mean, yeah, specifying them by hand like this, that's gonna be not great. As far as generation goes, like, this is fine. Actually, this reminds me, do we have const expert in C? Temp. Like, is that a thing that can exist? No. Wait, I mean, I'm pretty sure it is in C23. But I guess not. Unless I'm, hold on. C23 compiler support matrix. Const x. Okay, apparently GCC has that. But like, that's it. Pound embed, of course, is that making it into C++? What is the purpose of the embed direct? I mean, maybe? I mean, unclear. Unclear if pound embed is making it. No example. Yeah, because no compiler supports it. Okay, well, const expr is also not supported, except in GCC. Yeah. So how is this gonna work? So this is one place where it's relevant, where how many MIPS you have is relevant. This is another place where it's relevant. And this is kind of another place where it's relevant. And also, if you just change... well, actually, that's an interesting thing. What happens when you change it at runtime? One of these MIPS. Does get keyboard state, but it only gives us like up and down data. If the higher bit is up, if the key is a toggle key, then the lower bit is meaningless for non-toggle keys. Oh. Okay. Yeah, this needs to be changed a little bit if we're gonna respond to key presses. Because we know when a key is down, but we don't really know when a key is pressed. Pressed meaning that it wasn't down, and it was, and we got a key down message. So we got a key down message, but it wasn't down before we got the key down message. Which means input. Okay, well. Yeah, we kind of need to keep track of these things. We're not using the mouse right now, so it's just keys. Keys, input, key, keys, input, key ID, count. Input key. I mean, right now we just have left and right pretty much. But we can also have like toggle scaling. Input key. Also, it's not input key, this is input key ID. I suppose none would be good to have as well. Except it's not a struct, it's an enum. Okay, what's input key? Bool ended down. Oh, I guess just down. It's fine. Input, zero it out. And then in here modify it. Well, whenever we get the down message, we just set it to down, and whenever we get the up message, we set it to up. Except we need to map. We need to map Windows keys to our keys. Well, input key ID. Key is input key ID none. Switch on a message W param. Case VK left. I mean, this where's this? Yeah, this loop just ends here. Yeah, let's just do it this way for now. Key is input key ID right, I mean, well, left. Key is input key ID right. And then bool down is bool down is what? Is message equals WM key down. And then input keys key. I mean, yeah, we don't really need an if statement there. Input key is key equals down. I mean down. Down equals down, and input keys, well, do we need anything other than down? Yes, because we need to know if it was pressed or not. Half transition count, sure, why not? I mean, that works. I guess we're not going to be clearing the keyboard and well, while we're here though. Kill fuck because like Alt Tab will kill the focus, but then you'll detect the Alt down, but you won't detect the Alt Tab. So you'll think Alt is down, so that's always a problem. Okay, so now I guess we don't need to do this so much. Input keys, input key ID, left, right, whatever, down. Yeah, that's really all we need to know. Whether left and or right are down. Yeah, so that lets us move around. And now we can also toggle scaling. Just bind it to some key. VK. Up works. Yeah, of course we're not responding to toggle scaling, but we should. Well, I mean, we are storing the sprite scale multiplier thing just in C buffer, which is probably not what we want to do long term. But C buffer, yeah, so that's just stored in here along with camera position. And when you toggle it, well, for now we can just write something like, well, you know, if input was pressed, input, and then what? Input key ID toggle scaling. If was pressed, then do something. Bool, not static, bool was pressed. Input key ID. Input keys ID. So if it's down and speaking of, oh yeah, and input, well, input key is that, key down and key half transition count is greater than 1, that means greater than 0. or key is not down, and I'll actually, if half transition count is greater than 1, then it was pressed. There. Okay, so if it was pressed, then I need to do something about that sprite scaling multiplier. Well, right now it's just going around, say the 0 or 1. So like one thing that would have to change is this. Another thing that would have to change is all the MIPS would need to change. And all of them are stored in the same array. So presumably sprite rect array is that. So that's the array. Okay. For index is 0, index is less than lang index plus sprite rect is that plus index. Okay, so that is the rectangle. And rect, you know, text and atlas, like this needs to change. And the way MIPS are working, plus MIP delta, like this is either +1 plus equals. Yeah, so this MIP delta is either 1 or it's like go back to the start. So in this case, -1. But with 3 MIP levels, it would be +1 or -2. And that would be it, actually. Like, we don't actually need anything else. Like, this is it. Well, with only 2 MIPs, we can just say that, well, current MIP index is, well, I mean, it's this. We can derive it out of this, really. I mean, it's like if you cast it as an int and then subtract 1 and then just count ones. Is there what's clang count zeros? Leading zeros, sure, that works. Opinion based. Built-in CLZ, that's right. Well, that's GCC. Does that work? 2 underscores. Yeah, so is there like a list of these things? I mean, I guess this is it. Okay, so built-in number of leading. Okay, so number of trailing. Okay, so number of trailing zeros and number of trailing ones. CTZ. Let's count trailing zeros. Well, sure, why not? I'll do it. Okay, this is current MIP. We do need to know how many MIPs there are. Total. MIP count. Okay, so this needs to go out somewhere. I mean, I guess we can stick them in here. 32 MIP count. Okay, so this is MIP index. We now know what the MIP count is. And given that we know what the MIP count is, so like soon next MIP index is current MIP index plus 1 modulo atlas locations MIP count. 2 MIP delta is next MIP index minus current MIP index. Something like this. Oh yeah, Sprite Rect actually has... Oh yeah, it has the actual rectangle where the texture is. I mean, this could just be an array of, you know, of that many, and then we just pass in current MIP index and have the of course, if that's an array, yeah, there's gonna be some issues with... Yeah, if we could just... Well, we are gonna have to work this out. For sure. For sure. No matter what, we have to work out the current MIP index. And the next MIP index. And I'll pass that in. Texture positions aren't gonna change. The position in the rectangle array does not tell us anything about what texture it has. Yeah, so Sprite Rect doesn't actually know the ID of the texture. which, I mean, we could either store all of them, or we could just store the ID. But someone has to do the lookup. So at some point you are gonna have to connect the ID to the... and as far as the GPU goes, it's probably gonna be better for debugging and stuff if we just pass in one set of coordinates rather than many. But then if we're passing in only one, then someone else has to store the ID. Unless we have a sprite rect for the GPU and then we have a sprite rect for ourselves, that's the different one. That's like, let's say this is sprite rect GPU and this is sprite rect hours, and this actually has Atlas ID. Like that. Now I suppose we just do that with the ID. And well, there's multiple errors there. Man, synchronizing these though, like that is not amazing. Well, I mean, these are common. Just this is different. I mean, I guess we could just add the Atlas ID to the sprite rect and then just nibble it. I mean, no, I mean, I think we can. Yeah, I think we can just do that. Position, offset, then the texture, and then the ID as the last thing that's in there. Okay, what's this? Excuse me. No, there are no. Okay, so rect ID now changes in this manner, and then rect dex and atlas just have to be atlas locations pointer rect ID. Alright, let's see how well that works. So we press up, and presumably we didn't. Okay. Why are we here? Why are we here? Oh, what's going on? Where's there it is. key half transition count. Oh wait, we're not clearing the half transition counts. Static. I mean, I guess this could just be done here. Well, fuck. Yeah, let's just leave it line 2. Yeah, this is risk of rank 1. I mean, if I wanted to clone risk of rank 2, I would have called it, you know, risk of rank 2 clone. Input ID count, key ID. Yeah. Input keys plus key ID. Well, input keys, key ID 0. Did I modify something in STB as printf? Oh, I did. Amazing. Well, now was pressed should presumably be working. Oh wait, we're not doing... Oh, we are doing key down and key up. No, this is fine. It wasn't pressed, apparently. No, it's not end. Okay. Okay, where are we? Oh, we're here. Okay, well, alright, there we go. Is there... Interesting. Is there a way to toggle disassembly? There is. Open disassembly view. Toggle source code in disassembly view. Oh, there is. Okay. Well, looks like it's... Oh, it's a Visual Studio style disassembly view as well. Well, looks like it is using built-in instructions for that. Actually, can we like transition to... Like, can we step through that? No, we can. Interesting. Oh. Well, anyway, what's the current MIP index? 1, which is correct, yeah. Next MIP index is 0. MIP delta is -1. Oh yeah, this needs to change. I mean, it's a power of... we start at 1, and if the next MIP index is 0, is 4i32 power index, I guess. Power index is less than next MIP index. Yeah, that'll do. Just multiply it by 2. That many times. That'll do. Press up. Alright. Keep pressing F8 instead of F9. Alright. 0, 0, so sprite scaling multiplier is 1. Okay. Now we never set the ID. Yeah, that'll be... Okay, let's remove most of these. Yeah, it's kind of annoying to have to do that, but well, let's just see if that works even. Now there's only one of them. So the rectangle is that, and mip delta is -1, so now the rectangle is pointing to that first one. And texture in Atlas changes appropriately. Yeah. So now press up again. 0, next one is 1, mip delta is 1. That starts at 1, and then we multiply it by 2 once, so it's 2. There's that rect, add. Now it's the second one, and the text changes. So, I mean, it does work. And this is what it would take to switch them at runtime. I mean, it's not too bad. Not too bad. And it is being passed in correctly. Presumably because well, let's see why that is exactly. When I copy the rectangles, yeah, well, when I copy the rectangles, by doing this, yeah, it's just a mem copy. Okay, so I am copying the ID. It's just not specified in the shader that it's there. And does that work? Yeah, it works because interesting. So we're calling it we're setting the total size of the buffer. But do I at any point specify the stride? I mean, that's just the buffer, like... Yeah, that's just the buffer with no description of anything. Now in here, Again, nothing here says that it should be... Okay, when I'm setting the buffers, hold on. Maybe it's at the buffer setting time, which would be draw rects. Okay, well, yeah, so draw rects knows something about the size. Rect size. So that is the stride. Yeah, so it should still work then. Let's have two of them. One is mirrored. Well, they are both being drawn. This is all fine. So just stick with this then. Stick with this implementation. Well, I would definitely need something to... I mean, like no matter what, at some point you have to map the ID to the texture, and you have to keep the IDs around. Because they're changing. So it's like no matter what, this will be somewhat of a problem. Alright. Is there anything obvious that needs to change? Probably not. Let's turn on everything else. Yeah, screen pixels, those don't need to keep the IDs around. Well, yeah, so that's scaling up and down just fine. And adding MIPs shouldn't... Okay, let's see how much stuff needs to change to add a MIP level. Well, this needs to change. I mean, why not? Just call it that. And this would be like duplicated for every frame of every animation. That definitely need to auto-gen that. Nothing here needs to change. MIP count needs to change, okay. Auto-gen MIP. MIP count would be relevant for generating the atlas IDs. Yes, all of this Yeah, all of this I think doesn't change. This doesn't change. What changed here? Oh yeah, I just renamed it. Well, this is just the one we're starting with, so that's fine. And these, well, these need to be synchronized with the starting scale. Although all of this will go away eventually, so... None of this changes. Does this changes? Does this change? I don't think this changes, no. Alright, so is that all we have to do then? Okay, well, not that many places need to change to make this work. Oh my god. Right. Does it flip around the right way? It should flip around here. Yeah. Ah, that's not so bad. Yeah, I'll stick with this. And how much? So we've got 1, 2, and 4. And I guess 8 would be another one to add. Yeah, I mean, if there are like, 50 of these, then then autogen is a must, pretty much. There is no way you'd be able to synchronize them by hand. 1, 2, 4, 8. Alright. Oh my god, did I just closed it? Yeah, I mean, you can see a bit of dithering there, like on the edges when it's small. But it's either that or it jitters from one pixel to the next. So I suppose this will do. Okay, let's see. So removed white pixel, that's good. Focus. Okay, so input, this whole thing. Yeah, that's probably the next thing to do. Although, I mean, I can set up for that. Like, if we're gonna be auto-genning these things, then it's gonna look like this. That's it. Yes. All right. Maps, yeah, those are done. I mean, that's not too bad. Actually, let's look at them and run the talk. Yeah, looks about right. Oops. Yeah. And the shader changed. Yeah. Yeah, that looks about right. Add maps for sprites. Okay, so what other to-dos? Autogen, autogen. Those are different autogens. And this one's more important than that one. Sprite offsets, kill focus. Well, yeah. Nice buttons like Alt. I mean, Siski down. Whenever you have Alt held down, if you press anything, that counts as a sys key. Up, or sys key down. And I think that's the only key that, oh god, that triggers that. No? Oh, mouse move. Yeah, well, mouse move is different, of course. Okay, so if I just press, like, any key, space, shift, escape, F1, like, none of those are sys keys, but if I press Alt, that's a sys key. And Alt plus anything, while Alt is held down, anything else is also a sys key. So with the kill focus message, we could either just ignore the Alt key, or if we are going to intercept the Alt key, then whenever there is a kill focus, input needs to be cleared. Well, for now we're not intercepting the alt key, so that I guess that to-do can just stay there. And we'll see if we actually need to do any of that. Yeah, like render dog doesn't seem to respond to the alt key. A Sprite does though. Yeah. And if you alt tab and then alt back in, alt key is just permanently held down until you press it again. Okay, so it's only a problem if you're actually responding to the alt key, and it's not really a problem otherwise. Alright. Yeah, because other than this enum for Atlas locations, the next thing would be to do animations. But then it would be something like come on, like walk 1, 2, 3, 4. I mean, there's frames, right? So it would be walk, you know, like walk 1, like as in frame 1, and then it would be like frame 2, 1, 2, 3, 4, 1, 2, 3, 4. Yeah, this is gonna get out of hand very quickly. So not doing that by hand, definitely. Okay. Well, I think everything's set up for auto-generating this enum somehow. But yeah, not gonna do that today. Alright, that's all for today. Thanks everyone.